Hello. Once again, welcome you to the second session of surface areas and volumes. So, let's start. So, Exams Vidhai is a non-profit initiative of IIITDM Kancheepuram, where we give free coaching and resources to students to prepare for various competitive examinations. So, as we have seen the contents of this chapter, we have already seen 2D shapes and 3D shapes, surface area of different shapes. Now we are going to see the volumes of different shapes. And later in the further sessions, I'll be covering conversion of one shape to another and frustum of a cone. So let's start. So volume of different shapes. So we learned in the first session that volume exists only for 3D shapes. So 3D shapes are nothing but three-dimensional shapes or the solid shapes which have length, breadth, and height. So volume of a 3D shape is nothing but the total space enclosed by the body or the object occupied by any three-dimensional object or solid shape, like it can be a sphere, cone, cube, cuboid, or any other 3D object which you see in your everyday life. It could be a book, it could be a mouse, it could be your table, it could be a bucket, etc. So now let's see the volumes of different shapes, 3D shapes. So, cube. The volume of a cube is side into side into side. That is side cube. Whereas volume of a sphere is 4 by 3 pi r cube. Whereas this is a cuboid. Now, volume of a cuboid is length into breadth into height. This is a cone, and volume of a cone is 1 by 3 pi into r square into h, where r is the radius of the base and h is the height of the cone. This is a cylinder, and volume of a cylinder is pi into r square into h, where r is the radius of the base circle and h is the height of the cylinder. This is a hemisphere. Volume of a hemisphere is 2 by 3 pi r cube, where r is the radius of the hemisphere. Now let us understand more about volumes of different shapes by solving a few problems. So let's start. Okay, this is the first problem. So a solid is in the shape of a cone standing on a hemisphere with both their radii. Radii means singular, whereas radius is plural. Radii being equal to 1 centimeter and the height of the cone is equal to its radius. Find the volume in of the solid in terms of pi. So here he's asking us to find the volume of the solid in terms of pi, which means we no need to substitute the value of pi. So let us understand the solid over here. So here the solid given to us is a combination of a cone and a hemisphere. So the total volume of the solid will be the volume of the cone plus the volume of the hemisphere. So let's see. Volume of the object is nothing but sum of the volume of hemisphere and volume of cone. That is, we know that volume of hemisphere is 2 by 3 pi r cube and volume of cone is 1 by 3 pi r square h. And he has given that the height of the cone is equal to its radius. That is, radius is 1 centimeter, then height also becomes 1 centimeter. So, substituting the values, we get pi as the final volume. One important thing is the units. You should never forget get the units. So here the units is centimeter cube. So that's it. Okay. Now let's see one more problem on volume of different shapes. So here a solid toy is in the form of a hemisphere surmounted by a right circular cone. The height of a cone is 2 centimeter and the diameter of base is 4 centimeter. Determine the volume of toy if a right circular cylinder circumscribes the toy. Find the difference of the volumes of cylinder and the toy. So the image is something like this. Over here, a cone is surmounted above a hemisphere, and this toy lies in the cylinder. So it appears like this. So we have to find the volume of the toy, that is the cone, volume of the cone, and the volume of hemisphere. And the toy is being circumscribed by the cylinder. So to find the difference of the volumes of cylinder and the toy, first we need to find the volume of cylinder and then the toy and subtract them in order to find the difference of the volumes of the cylinder and toy. So let's see how the procedure. So here BPC is the hemisphere and ABC is the cone standing on the base of the hemisphere. The radius BO of hemisphere is 2 centimeter. Since the cone is surmounted on a hemisphere, the total volume becomes volume of cone, volume of toy becomes volume of cone and volume of hemisphere. Their sum, that is this. Okay, let's see. We know that volume of cone is 1 by 3 pi r square h, where r is the radius and h is the height. And we also know that volume of hemisphere is 2 by 3 pi r cube. And he has given us here that pi should be taken as 3.14. On substituting the values, we get the volume as 25.12 centimeter cube. And next, calculating the volume of the cylinder. Over here, the right circular cylinder circumscribes the given toy. So the radius of the cylinder becomes 2 centimeters because the base of the hemisphere is same as the base of the cylinder. Hence, their diameters become same. So, their radius 2 becomes same. Hence, the radius of cylinder is 2 centimeters. Whereas the height is nothing but AO plus OP. That is the total height of cylinder. We know that the height of cone is given as 2 centimeter, and we know the radius of hemisphere is 2 centimeter. We know that radius is the distance from center to any point on the curved surface. So OP is also the radius. So OP is 2 centimeter. So the total height of cylinder becomes OA plus OP, that is 2 plus 2, that is 4 centimeter. So calculating the volume of right circular cylinder, that is pi r square h, that is 2 power 2. It's not 22. It's 2 power 2 into 4 minus 25.12. That is volume of toy. We get it as 25.12 centimeter cube. So this is the final difference of the volumes of cylinder and the toy which we get. So thank you for attending the second session. Hope you understood what was taught. Thank you.